All right, in the last set of notes, we were talking about chords that are perpendicular. In this set of notes, we're looking at chords that simply intersect. They may form right angles, but they don't have to. It does not say that they cannot be perpendicular. They could be, but they don't have to be. All right, so with that in mind, we have two theorems to work with. The first, if two chords intersect in the interior of a circle, which is what we see here, two chords that intersect in the interior, then the measure of each angle is 1/2 the sum of the measures of the arcs intercepted by the angle and its vertical angle. It's wordy, right? The measure of each angle. So I'm going to use as my example this angle here, angle JLK. The measure of the angle is 1/2 of the sum. So the measure of angle JLK is 1/2 of the sum of two things. Okay, now the sum of the measures of the arcs intercepted by the angle, so in this case the measure of this arc, JK, plus the arc intercepted by its vertical angle. So the vertical angle here to angle JLK would be this angle MLN. So if this is that vertical angle, then the intercepted arc for this angle would be here. And that's the other arc that is going to form the rest of our sum. So the measure of arc MN. So the measure of any angle is 1/2 of the sum of the intercepted arc and the intercepted arc of the vertical angle. Likewise, the same would be true to say that the measure of angle MLN equals the same 1/2 of this sum. Because these two angles have the same measure, remember vertical angles are congruent, then the measure of angle MLN here would also be 1/2 of this sum. Likewise, if I look at one of the other two angles, let's look at this angle here, angle MLJ. The measure of angle MLJ is 1/2 of the sum of its intercepted arc. So its intercepted arc would be arc MJ, the measure of arc MJ, plus the arc intercepted by its vertical angle. So the vertical angle's here, angle KLN. So that arc from K to N would be the other portion of that sum. So 1/2 of the sum of the two arcs. The one arc corresponding to the angle and the other corresponding to the vertical angle. All right, so that takes care of how intersecting chords determine arc measure or how we can determine the angle measure. Keep in mind that any two of these could be given and you're going to find the third, whatever it happens to be. All right, the second theorem. If two chords intersect in the interior of a circle, so same setup as before, then the product of the lengths of the two segments of one chord is equal to the product of the lengths of the segments of the other chord. Now keep in mind, product means multiply. So in this case, looking at chord JN, it has two parts, JL and LN. And there's nothing saying that those are the same length. In fact, here they don't look to be the same length. But it's saying the product of the lengths of the two segments of one chord. So the product of JL, whatever that length happens to be, times the length of LN. These two form one segment, JN. They form one chord, is equal to the two parts of the other chord multiplied together. So here the other chord would be segment MK. So our segments here would be segment ML, that length, times the length of segment LK. So the length of segment ML times the length of segment LK. So when we're looking at two intersecting chords, the two parts of one chord multiplied together will be equal to the two parts of the other chord multiplied together. And there shouldn't be any overlap at all. The only point that any of these have in common is point L. Nothing else. So with that in mind, we then have, with these two intersecting chords, we have a way to work with either the angle measures or the arc measures. And we also have a way to work with the segment lengths. And let's look at a couple of examples as to how those are going to work. Number one, we have two chords, A, B, and C, D, that intersect inside a circle, and we're asked to find the value of x. So according to our second theorem up above, the two parts of one chord multiplied together, so 18 times x, is equal to the product of the other two parts of the other chord, so 9 and 12 multiplied together. Okay, so 18 times x, can't do anything with that just yet. 9 times 12 gives us a value of 108. Divide both sides by 18 to find our value of x, which in this case is 6 units. And that takes care of number one. So when determining segment lengths, the two parts of one chord multiplied together equal the two parts of the other chord multiplied together. And number two, we're working with angle and arc measure. So on number two, find the value of x. All right, in this case, we can see that we have an 80-degree angle given here. Its intercepted arc, 5x minus 20, and the intercepted arc of the vertical angle. Remember, the vertical angle would be here. So according to the theorem up above, the 80-degree angle, the measure of the angle, is 1/2 of, so 1/2 times, the sum of the two arc measures. So 5x minus 20 plus 40. So here we have the two arcs added together. This is the angle formed at the intersection point. So do some combining like terms here. We end up with 5x plus 20. Now at this point you have a choice you can make. You can either distribute the 1/2 throughout this quantity, multiply the 1/2 times 5, multiply the 1/2 times 20, or you could multiply by 2 on both sides, which is going to get rid of this 1/2 entirely. And that's the route that I'm going to take just because I don't want to work with a decimal. And I know 1/2 of 5 is going to be a decimal. So I'm going to multiply by 2 on this side, and I'm going to multiply by 2 on the left as well. And that's going to give me some values here. I know that. Let's see, 2 times 80 is 160. In this case, the 1/2 and the 2 are going to cancel each other out, leaving 5x plus 20. So we subtract 20 on both sides to get 140 equals 5x. And divide both sides by 5 to get, 28 equals x. And we can go back and substitute this to double check our work, and that's always a good idea, as we all know. So if we substitute this value of x in here, in the 5x minus 20, then I get 5 times 28 minus 20. So 5 times 28 is 140 minus 20 be 120 in that case. So is 80 half of the sum of these two arcs? Well, if I add these two together, 40 and 120 make 160. Half of that is 80, which tells me my answer is correct. So with that in mind, that is how we work with intersecting chords, either dealing with segment lengths, as we see in example 1, or working with arc and angle measures, as we see in example 2.